Take a walk through your shop and look at the nameplates. If you see a machine from the 1950s or 60s, you aren't just looking at a tool. You are looking at a survivor. That machine was built during an era when precision was a matter of family honor, and over-engineering was a point of pride. Now, look at the high-speed CNC center that arrived 5 years ago. It's a marvel of efficiency, certainly, but while the old iron was built to be a permanent asset, the new machine was built to be a consumable. We've been told that this is the natural evolution of technology, that faster is always better. But if you've ever had a $250,000 machine go dark because of a proprietary software lockout or a cheap, non-serviceable circuit board, you know the truth. The quality of modern machinery wasn't killed by a lack of engineering talent. It was systematically dismantled by a boardroom philosophy known as shareholder value. Today, we are going to perform a forensic autopsy on the American machine tool industry to see exactly how we traded our industrial sovereignty for quarterly dividends. The history of the American machine shop is written in the smell of sulfurized cutting oil and the cold, heavy touch of stabilized cast iron. If you go back to the mid-20th century, companies like Bridgeport, South Bend, Hardinge, and Kearney and Trecker weren't just manufacturers. They were the high priests of precision. In Tulsa days, the men running these companies weren't coming out of Ivy League business schools with spreadsheets in their hands. They were coming off the shop floor. They were master machinists and engineers who understood that a machine tool was an investment meant to span generations. The philosophy of that era was over-engineering. When you looked at the ways of a lathe or the knee of a milling machine, they weren't just strong enough. They were designed with massive safety factors. Castings were left outside in the yard for a year or more through heat and frost, just to let the internal stresses of the metal relax naturally. This seasoning process ensured that once the machine was precision ground and hand-scraped, it would stay true for 50 years. Reputation was the only currency that mattered. If a machine failed prematurely, it wasn't just a warranty claim. It was a stain on the family name that sat on the nameplate. A Bridgeport mill from 1950 was more than a tool. It was a masterpiece of mechanical ergonomics. Every handle, every dial, and every dovetail slide was designed by people who knew what it felt like to stand in front of a spindle for 10 hours a day. There was a symbiotic relationship between the builder and the user. The builders knew that their customers, the small job shops that built American-needed equipment that was repairable, rigid, and reliable. If a lead screw wore out after 20 years of heavy use, you didn't scrap the machine. You ordered a new screw, or you turned a new one yourself, and the machine went back to work. But the seeds of decline were planted just as this golden age reached its peak. The transition began subtly. In 1968, the legendary Bridgeport Machines, Inc. was acquired by Textron. At the time, Textron was one of the world's first true conglomerates. They owned everything from Bell Helicopter to companies that made golf carts and zippers. To the engineers at Bridgeport, the buyout initially looked like a blessing. Textron had the massive capital reserves required to fund the move into the digital age. This was the dawn of numerical control, and eventually, computer numerical control. Without that corporate backing, many of the innovations that allowed American shops to automate might have taken much longer to arrive. However, this capital came with an invisible poison. For the first time, the people making the ultimate decisions about Bridgeport's future weren't looking at the scraping patterns on a machineway. They were looking at consolidated balance sheets in a boardroom in Rhode Island. The machine tool division was no longer a legacy to be protected. It was just another business unit in a diversified portfolio. If the aerospace sector was down, the machine tool sector had to squeeze its margins to compensate. The goal was no longer to make the best milling machine in the world. The goal was to achieve a specific internal rate of return. This was the beginning of the financialization of the machine shop. The masters of iron were being replaced by the masters of capital. The shift was gradual, at first a change in a bearing supplier here, a slightly thinner casting there, but the trajectory was set. The industry was moving away from the engineer's ethos and toward a new, colder doctrine that would eventually dominate every corner of American manufacturing: the absolute maximization of shareholder value. As we moved into the 1980s, the atmosphere in the American industrial heartland shifted from confidence to crisis. The threat wasn't just corporate mismanagement. It was the arrival of the Japanese machine tool giants. Companies like Mazook, and Fanuc were hitting the American market with CNC machines that were not only faster but significantly more affordable. The Japanese had mastered the art of mechatronics, integrating electronics and mechanics from the ground up, rather than bolting motors onto old manual designs. In a healthy industrial ecosystem, American companies would have responded by doubling down on research, development, and the legendary quality that made them famous. Instead, under the pressure of Wall Street and the growing influence of figures like Jack Welch, the response was a retreat into the spreadsheet. The shareholder value movement, popularized by economist Milton Friedman, argued that a corporation's only social responsibility was to increase its profits for its shareholders. Long-term brand loyalty, the welfare of the skilled workforce, and the generational durability of the product were all secondary to the stock price. This led to the birth of value engineering. In theory, value engineering is about maintaining function while reducing cost. In the hands of a 1980s CFO, however, it became a scalpel used to cut the meat out of the machinery. They began to ask questions that would have horrified the founders of South Bend or Hardinge. Does the base really need to be this thick? Can we replace this hand-finished bronze bushing with a plastic insert? Do we really need to season the castings? Or can we just heat-treat them and ship them next week? The result was a generation of machines that looked impressive on the outside but lacked the bones of their predecessors. The weight of the machines began to drop. Mass is a friend to the machinist. It absorbs vibration and provides thermal stability. But mass is an enemy to the accountant. It's expensive to cast, expensive to machine, and expensive to ship. So the iron was thinned out. The massive, hand-scraped dovetail ways were replaced by linear guides. While linear guides are fast and accurate for light work, they often lack the dampening characteristics and the sheer heaviness required for the kind of deep, punishing cuts that the old manual machines took in their sleep. To understand the full scope of this decline, we have to talk about the physical reality of the machines themselves. In a traditional shop, the rigidity of a machine is its most valuable asset. Rigidity comes from mass, and the way that mass is distributed. When you replace a solid, hand-scraped casting with a hollowed-out frame designed by an algorithm to save 5% on shipping weight, you change the harmonics of the machine. You invite chatter. You reduce tool life. But on a balance sheet, that 5% saving in shipping looks like a victory. This is the fundamental disconnect. The financial world views a machine tool as a commodity, while the machinist views it as a partner. When you optimize for the commodity, you sacrifice the partnership. Simultaneously, the workforce was being reclassified. The master craftsman who had spent 30 years at the same bench was no longer seen as an asset. He was a legacy cost. His high salary and benefits package were targets for restructuring. Companies began to shutter their apprenticeship programs, viewing the training of the next generation as an unnecessary expense that didn't show up on the quarterly profit and loss statement. They were eating their own seed corn. The shareholder value model also dictated a move toward outsourcing. To keep the margins high in the face of Japanese competition, American brands began to look toward Taiwan and eventually China. At first, it was just the small components. Then, it was the castings. Finally, entire machines were being built overseas, with the American brand name merely slapped on the sheet metal at the end. The symbiotic relationship between the local foundry, the local machinist, and the local community was severed. The value was being extracted from the community and the product and sent directly to the brokerage accounts of investors. By the turn of the millennium, the transformation of the machine tool industry into a financial instrument was nearly complete. This leads us to one of the most tragic chapters in modern industrial history: the fall of Hardinge Inc. For over a century, Hardinge was the gold standard for super-precision turning. If you were making parts for the Apollo missions or high-end medical devices, you had a Hardinge lathe in your shop. In 2002, Hardinge acquired the Bridgeport brand, a move that was seen as a bold attempt to consolidate American machine tool heritage. But the consolidation wasn't driven by an engineering vision. It was driven by a desperate need for scale to satisfy the hunger of public markets. Hardinge began a cycle of aggressive acquisitions, buying up companies like Jones and Shipman, Kellenberger, and Fork. On paper, it looked like they were building a global powerhouse. In reality, they were taking on massive amounts of debt to acquire brands that they then struggled to integrate. The focus shifted from manufacturing excellence to debt service. The final collapse of Hardinge in 2024, when they filed for bankruptcy, was the culmination of decades of this financial mismanagement. A liquidity crisis triggered by a failed asset sale in China and the crushing weight of high-interest debt proved to be the end. When a giant like Hardinge falls, it's not just a business closing down, it is the extinction of a specific kind of technical intelligence. When the production lines stop and the engineers are laid off, the collective memory of how to achieve submicron precision vanishes. You can't just restart that in 6 months. It takes years to build that culture of precision. But only one bad quarter and a nervous board of directors to kill it. This is the ultimate legacy of shareholder-first management. It values the liquidity of the asset over the longevity of the capability. It treats a precision tool manufacturer like a retail chain, failing to realize that once the manufacturing base is hollowed out, there is no coming back. But the death of quality isn't just about debt and bankruptcies. It's also about the fundamental change in how machines are built today. We have transitioned from the mechanical era to the mechatronic era, and in doing so, we have invited planned obsolescence into the machine shop. A 1950s lathe is an analog device. If a gear chips, you can see it. You can understand why it happened, and you can fix it. A modern CNC machine is a black box. The heart of the machine is no longer the spindle. It's the PLC and the motion control boards. These electronics are designed with a finite lifespan. Electrolytic capacitors, the tiny components that filter power on these boards, have a chemical lifespan. They dry out, they leak. Usually, this happens right around the 10 to 15-year mark. In the old days, a 15-year-old machine was just getting broken in. Today, a 15-year-old CNC is considered a liability. The manufacturers know this. In fact, many have embraced it. By controlling the software and the proprietary electronics, they have created a closed ecosystem. This is the rise of the repair monopoly. Take the example of John Deere, which has become the poster child for this issue, though the same logic applies to the machine tool industry. They have effectively separated the hardware from the software. You might own the 5 tons of steel sitting on your shop floor, but you only license the code that makes it move. If a sensor fails, the machine locks you out. You can't just bypass it or install a third-party replacement. You have to call the factory technician, who arrives with a proprietary laptop to handshake with the machine. You are paying $300 an hour for someone to click a button that you are legally and technically barred from clicking yourself. This is the final victory of the shareholder. They have figured out how to charge you for the machine twice, once when you buy it, and every year thereafter, just to keep it running. This digital shackling is a far cry from the independence of the traditional American machinist. The old-timers were proud of their ability to keep their shops running with nothing but a set of wrenches and their own ingenuity. Today's shop owner is often at the mercy of a tech support line in another time zone. This loss of control has a direct impact on the quality of the work. When a machine is down for 3 weeks, waiting for a proprietary board that costs $10,000, the shop owner has to cut corners elsewhere just to make payroll. The pressure to survive in a low-margin, high-overhead environment forced by these expensive, fragile machines leads to a further decline in overall manufacturing standards. We must also address the myth that quality is simply dead. It isn't dead, but it has been stratified. If you have $1 million to spend, you can still buy a machine that will hold tolerances for 20 years. Manufacturers like DMG, Morey, Matsuura, and Hermel represent the pinnacle of modern engineering. Their machines use polymer concrete bases for incredible dampening, sophisticated thermal compensation, and world-class spindles. But these machines are priced out of reach for the small job shops that used to be the backbone of the economy. The middle class of machinery are reliable, affordable, built to last tools that the average guy could buy and build a business in has been wiped out. You are left with a choice. Buy a cheap, disposable machine that will be obsolete in 8 years, or go into massive debt for a high-end machine that requires a specialized cleanroom environment to operate correctly. The death of the middle-class machine is a direct result of the pressure for high margins. It's hard to make a lot of money selling a machine that lasts 50 years and is easy to repair. There's no recurring revenue in a machine like that. Wall Street hates products that don't need to be replaced. They want cycles. They want churn. They want you to trade in your machine every 7 years, just like you trade in your car. But a machine tool isn't a consumer good. It's a capital good. It's a tool for creating wealth. When you turn capital goods into consumer goods, you undermine the very foundation of an industrial economy. You trade long-term productive capacity for short-term consumption. We also have to consider the global perspective. While American icons were being sliced up by private equity and conglomerate boards, other nations took a different path. De Herman Mittelstand, the small and medium-sized family-owned companies often resisted the urge to go public. Because they aren't beholden to quarterly stock price movements, they can afford to think in terms of decades. They can afford to keep their master craftsmen and invest in long-term. They stayed focused on the product, not the share price. As a result, German machinery remains a dominant force in the high-end market. They didn't fall into the trap of value engineering their reputation away for a temporary bump in dividends. As we look at the wreckage of brands like Bridgeport and Hardinge, we have to ask ourselves, was it worth it? The shareholders might have seen their portfolios grow in the short term, but the industrial base of the nation has been hollowed out. We have lost the ability to manufacture the machines that manufacture everything else. We have traded our sovereignty for efficiency. Every time a shop owner struggles with a software lockout or a blown board that can teberate, they are feeling the real-world consequences of a decision made in a boardroom 40 years ago. The quest for shareholder value turned out to be a suicide pact for American precision. To understand why the middle class of machinery vanished, we have to look at the hidden costs of the mechatronic revolution. In the 1940s and 50s, the cost of a Bridgeport mill was tied almost entirely to the weight of its iron and the hours of skilled labor required to hand-scrape its ways. But as the industry shifted toward the shareholder value model, the cost structure moved from the physical to the digital. Today, the value of a machine is often tied up in software licenses and proprietary control systems. This shift created a massive gap in the market. On one side, you have ultra-cheap, imported hobbyist machines that lack the rigidity for professional work. On the other, you have elite manufacturers whose equipment is so technically advanced and so expensive that it is inaccessible to the independent job shop owner. This stratification wasn't an accident of technology. It was a deliberate byproduct of corporate consolidation. When giants like Textron or later Hardinge Inc. began acquiring smaller, independent brands, their goal was to eliminate the very competition that kept quality high and prices fair. By buying up the icons of the industry, they could effectively control the entry point for new machinists. If you wanted a professional-grade mill, you had to buy from a conglomerate. But because these conglomerates were obsessed with quarterly dividends, they had no incentive to build a machine that would last 40 years. In fact, building a durable, repairable machine was seen as leaving money on the table. They realized that the real profit wasn't in the initial sale, but in the tailed decades of service contracts, proprietary parts, an inevitable replacement when the software became obsolete. We must address the technical forensics of this decline, specifically in the realm of metal. The seasoning of cast iron is a process that has largely been abandoned by manufacturers because it doesn't fit into a high-sped supply chain. In the Golden Age, raw castings were left in the yard for months or years to allow the internal stresses of the cooling metal to equalize. If you machine a green casting one that hasn't been seasoned, metal will continue to move and warp as those stresses release over time. This means a machine that is accurate on the day it leaves the factory can become a crooked, vibrating mess 3 years later. Shareholders cannot wait for iron to sit in a yard. They want that iron turned into revenue immediately. Consequently, modern manufacturers rely on vibratory stress relief or heat treatment. While these methods are faster, many veteran machinists argue they never truly achieve the same long-term stability as natural seasoning. This leads us to the geopolitical divorce in manufacturing philosophy. While the United States leaned heavily into the Milton Friedman model of shareholder supremacy, other nations, most notably Germany and Japan, maintained a different approach. The German Mittelstand model is characterized by privately held, often family-run companies that prioritize long-term stability over short-term stock bumps. Because these companies don't have to answer to Wall Street analysts every 3 months, they can afford to keep master scrapers on the payroll. They can afford to invest in apprenticeship programs that take a decade to pay off. Therefore, while American brands like Bridgeport were being traded like baseball cards between conglomerates, German and Japanese firms were doubling down on technical excellence. They understood that a reputation for quality is a moat that is very difficult to bridge, but once you lose it to value engineering, it is nearly impossible to reclaim. The impact of this shift on the American machinist has been nothing short of a crisis of independence. The rise of the repair monopoly, exemplified by the integration of software into hardware, has turned owners into renters of their own equipment. This is a central conflict in the modern shop. The machine is technically more capable than its manual predecessor, but it is far more fragile and far more expensive to maintain. In the 1950s, if a South Bend lathe had a mechanical issue, you could fix it yourself. But today, a general fault on a CNC screen can mean anything from a broken sensor to a corrupted firmware file. Because the manufacturers refuse to release schematics or error code keys, you are forced to pay for a factory-certified technician to travel to your shop just to plug in a laptop. This is the digital equivalent of a feudal system, where the shop owner is the serf and the manufacturer is the lord who controls the means of production. However, the history of the shop suggests that every conflict eventually creates a counter-movement. We are currently seeing a massive surge in the right-to-repair movement, specifically within the industrial sector. Machinists are a naturally rebellious group. They are people who build things for a living, and they don't like being told they aren't allowed to fix their own tools. This has led to the rise of old iron retrofitting. Across the country, small shops are hunting down discarded Bridgeport or Kearney and Trekker castings from the 50s and 60s. They are taking these massive, seasoned iron frames, which are often stiffer and more stable than anything made today, and stripping them down to the bone. They replace the old lead screws with high-precision ball screws and install open-source CNC controllers like Linux CNC or This Frankensteining of machinery is a direct response to the shareholder value era. It represents a return to the engineer's ethos. These retrofitted machines don't have planned obs. They don't have proprietary software locks. If a board fails, the owner can buy a replacement on the open market for $50 and install it themselves. It is a way for the independent machinist to reclaim their sovereignty and prove that the era of disposable machinery isn't an inevitability, it's a choice that we can choose to walk away from. The collapse of Hardinge Inc. in 2024 should serve as the final warning for the industry. When you stop being an engineering company and start being a financial holding company, you are living on borrowed time. The bankruptcy of such an iconic brand is a testament to the failure of aggressive acquisitions and debt-leveraged growth. It proves that you cannot simply buy a brand's reputation and then hollow out its quality without consequences. The market eventually realizes that the nameplate no longer matches the product. As we conclude this reconstruction, we must ask, what is the real price of efficiency? We have gained speed, but we have lost longevity. We have gained automation, but we have lost repairability. We have maximized value for the person who owns the stock, but we have destroyed value for the person who actually uses the machine. The story of modern machinery is a cautionary tale about what happens when the masters of capital forget that their wealth is built on the backs of the masters of iron. The next time you walk through a shop, look past the shiny sheet metal and the flashing lights. Look at the bones of the machine. Is it built to last? Or is it built to be? The quality of our work and our industrial future depends on our ability to demand better tools. We need to stop valuing the quarterly dividend and start valuing the 50-year spindle. Because in the end, you can't build a civilization on a spreadsheet. You build it on the rigidity of the iron and the precision of the cut. Keep your oil clean, keep your ways greased, and never stop fighting for the right to fix the things you own. The era of the Iron Masters may have been wounded by the boardroom, but as long as there is an old Bridgeport humming in the corner of a garage, it isn't dead yet. The true legacy of a machine tool isn't found in the company's stock price, but in the parts it produces and the people it empowers. For decades, we were led to believe that the financial health of the corporation was synonymous with the technical health of the industry. We now know that was a lie. We watched as the giants of our childhood were sold, gutted, and discarded. We watched as precision became a luxury instead of a standard. But the iron is still there. The knowledge is still there. And as long as there are shops where the quality of the finish matters more than the return on equity, there is a chance to turn things around. We are entering a new phase of industrial awareness. The fascination with the new and disposable is beginning to wear off. People are starting to realize that a machine you can't repair is a machine you don't really own. We are seeing a renaissance of mechanical skill, as younger machinists discover the magic of a hand-scraped way and the unmatched reliability of an analog control. This isn't just nostalgia, it's a survival strategy. In a world of fragile supply chains and software-locked hardware, the person who can maintain their own equipment is the only one who is truly free. So, let the boardrooms chase their quarterly targets. Let the conglomerates merge and purge until there's nothing left but a logo. We will be in the shop, making chips, holding tolerances, and keeping the old iron alive. Because at the end of the day, a spreadsheet doesn't make parts. A master of capital doesn't understand the resonance of a cutting tool. Only we do. And that is a value that no shareholder can ever truly take away.